Okay, dear students, once again, welcome back to another important chapter and vital chapters of class 12 mathematics. Okay, integration. I hope you are seeing, are you able to see it? Yes. So integration is one of the vital chapter of your mathematics. It has wide application in various field of science. Mostly in physics you will find. Okay, understand? Okay. So and also you'll find out how to find out the area under the curves. In geometry also you will find the wide application in calculus, okay, in coordinate geometry. And okay, yes, so let's see all of you. I hope you will enjoy this class, and I also have discussed the most of the vital formula for you in this concept in this class. Okay, I hope you will watch it carefully again and again and remember the formula and practice it. Okay, let's see the first point, and is the integration. I've written here what is integration, the concept. First point, integration. Okay student, what is integration? Yes, the integration is the inverse process of differentiation. Yes, integration is the inverse process of differentiation. Okay, our integration is also known as primitive or antiderivative. Okay, primitive or antiderivative. What is the other name of integration? Primitive or antiderivative. Okay, here point 3 is saying that integration of the antiderivative or primitive means to find the original function whose derivative of the function is given. The objective of integration is that a derivative of the function given. We know a function is given, we have to find out the derivative. All of you know how to differentiate, how to find out the derivative of given function. If function is given, we are going to find out the derivative. But in the integration we are studying, the derivative of the function is given. We have to find out the original function whose derivative is known. Okay, and here derivative of the function is given, we have to find out the original function. Okay, so the process of finding the functions original function whose derivative is given is also known as differentiations or integrations or primitive. Okay, yes, let's see next point. Let us consider the following examples. We know that the derivative of sin x is what? What is the derivative of sin x? Cos x. So cos x is the derivative of the function sin x in alternatively. In other words, we can say. And here cos x is the derivative. If I will ask you, if cos derivative of the cos x, which is the, yes, cos x the derivative of which function? If I will ask you to this question to you, so what will be the answer from you? Yes, cos x is the derivative of which function? Which function? Yes, naturally your answer will be sin x. Yes or no? Yes, so the cos x is the derivative of the sin x. So we say that sin x is the antiderivative or primitive or integration of the function cos x. Is it clear? Yes. Okay. And it is noted that for any arbitrary real constant, the derivative of the function is always what? 0. And derivative of the constant function is always 0. So the antiderivative of the given function is not unique. Because if you can write also, the derivative of sin x plus c is also what? Cos x. Derivative of sin x is cos x and derivative of sin x plus c is cos x, where c is any real constant, any arbitrary real constant, any arbitrary real numbers. So if you take in place of c any real number, so derivative, okay, sin x plus c is always constant, which is cos x. Yes, because c is a constant and derivative constant function is what? 0. So derivative of sin x plus c is equal to cos x. Okay, it is clearly understood that the antiderivative of a given function is not unique. Is not unique. Look at here in this point. Since the derivative of sin x plus c is equal to cos x, so sin x plus c is equal to family of antiderivatives of cos x. Because if we can take the in place of c any real number, we shall get the different function. Okay, and the derivative of that function is constant cos x. Yes or no? Sin x plus 1 is equal to cos x. Sin x plus 2 is equal to cos x. Sin x plus 3 is equal to cos x. It means derivative of sin x plus 1 is equal to cos x. Derivative of cos x plus 1 is also Yes, derivative of sin x plus 2 is also cos x. Yes, the derivative of sin x plus 3 is equal to cos x. It means in place of c, we can take the different type of real numbers, any real number. So derivative of sin x plus c and its derivative is always cos x. Okay, it means it is clear that sin x plus c is called family of antiderivative of the function cos x. So there are infinite number of antiderivatives of a given function. Is it clear that there are infinite number of antiderivatives of a given function? So the antiderivative of cos x is sin x plus c, where c is arbitrary real constant and c is called constant of integration. Okay, yes. So in this point you see, so the sin x, if sin x plus c is the antiderivatives of the function cos x, we can write it as, okay, integration of cos x with respect to x, which is sin x plus c. How can we write the integration of cos x with respect to x is equal to sin x plus c, or integration of cos x dx is equal to sin x plus c. And how can we read this is the indefinite integral of cos x with respect to x is sin x plus c. Why it is called indefinite integral? Because why? Because of the constant of integration. Because a function has infinite number of antiderivatives. Yes or no? Yes or no? If cos x is the function, the cos x the derivative of not a unique function. Cos x is not the derivative only sin x. Cos x the derivative of sin x plus 1. Cos x is the derivative of sin x plus 2. And cos x is the derivative of sin x plus 3. So the derivative of cos x is not a unique value. So the cos x, so the antiderivative of a function cos x has not unique value. It has infinite number of antiderivatives or primitives. Thus, there are infinite number of antiderivatives. That's why integration of cos x dx is equal to sin x plus c. Yes, so sin x plus c is known as family of antiderivative. Yes. Okay, so if derivative of fx plus c is equal to small fx, then you can write integration of fx small fx dx is equal to capital Fx plus c, where capital Fx plus c is known as family of antiderivative of the function small fx. Okay, yes. So integration of fx dx is read as integral of fx with respect to x. How to read this symbol? How to read? The integration of fx dx can read as integral of fx with respect to x. The process of finding the integral of function is called integration. Yes, what is integration? The process of finding the integral of function is called integration. Yes. Similarly, if derivative of one example, simple example I have taken here, if I'll ask you and already know also, if the derivative of x cube upon 3 is equal to x square, then what is the integration of x square with respect to x? Naturally, you will say x cube by 3 plus c. Yes, understand? Just reverse. You can clearly understand the how the integration is the opposite process, the reverse process of differential derivative. Yes, here you see another point. Yes, similar next point you see derivative of e to the power x plus c. All of you know derivative of e to the power x plus c is what? E to the power x. Similarly, if you can write reverse process, how can you write? Yes, can you tell me? Yes, you can tell. So integration of e to the power x dx is equal to e to the power x plus c. Integration of e to the power x dx is equal to e to the power x plus c. Yes. Similarly, derivative of x to the power 4 minus 6x is equal to 4x cube minus 6. So integration of 4x cube minus 6 with respect to x. Naturally, it will be x to the power 4 minus 6x plus c. Yes. So minus x square plus c, sorry, x square minus 6x plus c is the antiderivative of what? 4x cube minus 6. Similarly, derivative of log x to the base e. Yes, derivative of log x to the base e is 1 by 1 upon x. Yes, so if you write in reverse order, so integration of 1 upon x dx or integral of 1 upon x with respect to x, naturally it will be what? Log x, log modulus of x to the base e plus c, right? Okay, so point 16 is saying, next point is saying that the derivative of a to the power x upon log a to the base e is equal to a to the power x, where a is greater than 0 and a is not equal to 1. Similarly, if you write in reverse process, the integration of a to the power x with respect to x, so integration of a to the power x dx is equal to a to the power x upon log a to the base c plus c. Same process. If the derivative of minus cos x is sin x, derivative of minus cos x sin x, all of you know. Yes. So if you write simply integration of sin x dx is equal to minus cos x plus c. Yes. Similarly, derivative of sin x plus cos x is equal to what? Derivative of sin x is equal to cos x. So integration of cos x dx is equal to sin x plus c. Yes. So derivative of tan x is equal to sec square x. So what is the integration of sec square x dx, which is tan x plus c? Yes. Similarly, derivative of minus cot x is cosec square x. So integration of cosec square x dx is equal to minus cot x plus c. These are the very vital formula I am discussing, students. These are mostly useful in solving, in finding the derivative, the integration of given different type of functions. Okay. So you have to remember these functions. You have to remember this formula also. Okay. So derivative of sec x is equal to sec x into tan x. So integration of sec x into tan x dx is equal to sec x plus c. Similarly, derivative of minus cosec x is equal to cosec x into cot x. So integration of cosec x into cot x dx is equal to minus cosec x plus c. Okay. Understand? So try to remember this formula. Yes. Yes. Similarly, derivative of log sin x is equal to cot x. So what is integration of cot x dx? Which is naturally log modulus of sin x plus c. Okay. So derivative minus log cos x is equal to tan x. So integration of tan x dx is equal to minus log modulus of cos x plus c, which is, we can write also log modulus of sec x plus c, because the minus sign is here. So we can write log modulus of sec x plus c. Okay. So I hope you will remember this formula. Yes, these are the vital formula. If you know the derivative, you can remember the integration. Yes. Next point, derivative of log sec x plus tan x is equal to sec x. Derivative of log sec x plus tan x is sec x. Yes. So integration of sec x dx is equal to log modulus of sec x plus tan x plus c. Similarly, derivative of log cosec x minus cot x is equal to cosec x. So integration of cosec x dx is log modulus of cosec x minus cot x plus c. Okay, integration of cosec x dx is equal to log modulus of cosec x minus cot x plus c. Similarly, derivative of sine inverse of x is equal to 1 upon 1 minus x square root over. If you say in reverse manner, so integration of 1 by 1 minus x square root over dx is equal to sine inverse of x plus c. In the same process, derivative of sine inverse of x upon a, you see, derivative of sine inverse of x upon a is equal to 1 upon s square minus x square root over. So what is the integration of dx upon s square minus x square root over? Is naturally equal to sine inverse of x upon a plus c, right? Okay. So derivative of cos inverse of x is minus 1 upon 1 minus x square root over. So integration of minus 1 upon 1 minus x square root over dx is equal to cos inverse of x plus c. So derivative of cos inverse of x is equal to minus 1 upon s square minus x square root over. Similarly, if you say that integration of minus dx divided by s square minus x square root over is equal to cos inverse of x upon a plus c. Same process, another formula I am telling. Derivative of tan inverse of x is 1 upon 1 plus x square. So integration of dx upon 1 plus x square is equal to tan inverse of x plus c. Right? This is also another important formula. D upon, so similarly, derivative of 1 upon a tan inverse of x upon a is equal to 1 upon s square plus x square. So integration of dx upon s square plus x square is equal to 1 upon a tan inverse of x upon a plus c. Okay. Next point, next formula is derivative of cot inverse of x is equal to minus 1 upon 1 plus x square. So integration of minus 1 upon 1 plus x square dx is equal to cot inverse of x plus c. Okay, students? Yes? Okay. Okay, next formula is that, so derivative of 1 upon a cot inverse of x upon a is equal to minus 1 upon s square plus x square. So integration of minus 1 upon s square plus x square dx is equal to 1 upon a cot inverse of x upon a plus c. Plus c you can use. Plus c. Yes? Understand? So derivative of sec inverse of x is equal to 1 upon x whole into x square minus 1 root over. So integration of 1 upon x whole into x square minus 1 root over dx is equal to sec inverse of x plus c. Yes. So derivative of 1 upon a sec inverse of x upon a is equal to 1 upon x whole into x square minus s square root over. So integration of 1 upon x whole into x square minus s square root over dx is equal to 1 upon a sec inverse of x upon a plus c. Okay. Similarly, last point I am talking, and 1 upon a derivative of 1 upon a cosec inverse of x upon a is equal to minus 1 upon x whole into x square minus s square root over. So integration of minus 1 upon x whole into x square minus s square root over dx is equal to 1 upon a cosec inverse of x upon a plus c. So students, these are most vital formula I have already discussed, and you try to remember, practice it, and use it, and solving different kind of problems. Okay, and once again see. Here you see the integration concept of integration. I am in this class I am going to discuss the definition and concept of integration, meaning of the integration. Yes, and important vital formula. Look at here. The integration is the inverse process of differentiation. Integration is also known as primitive or antiderivative. Once again, look at, note down also. Yes, here integration or the antiderivative or primitive is to find out the original function whose derivative of the function is given. So the process of finding the function whose derivative is given is also known as antidifferentiations or anti-integrations. Yes. Okay. Here I have explained with the help of the meaning of the integration, meaning of antiderivative with the help of simple example. And all of you know derivative of sin x is cos x. So cos x is the derivative of sin x. It means sin x is the antiderivative of cos x. Yes. Once again see, since the derivative constant function is 0, so antiderivative function has infinite number of antiderivatives. So derivative of sin x plus c is equal to cos x. Uh, so there are infinite number of antiderivative because of the constant of integration. Because so it means a function has infinite number of antiderivatives. Yes. Here you see this page how to return derivative of sin x plus c is cos x, and sin x plus c is also known as antiderivative of the cos x. Yes, and c is the constant of integration. So a function has infinite number of antiderivatives. Yes. Okay. So how to write the integration of cos x dx is equal to sin x plus c. How to read integral of cos x with respect to x is sin x plus c. Yes. Here, and I have explained the derivative of capital Fx plus c is equal to small fx. So integration of fx small fx into dx is equal to capital Fx plus c, and capital Fx plus c is known as family of antiderivative of the function small fx. Right? Once again, look at here. Yes. Look at the formula, important vital formula. With the help of example we discussed, and practice it. Yes. Once again see. See once again this one. Yes. Okay. Once again see here. Thank you. Thank you, student, for interest in the class. I hope you will practice the formula, and it is most of the important chapter for integrations for your second term examination, and it has many implications. And I hope you will understand it, will practice it. Okay, and watch it again and again. Okay. Thank you, all of you. See you. Bye.